Hi all, welcome to the remastered version of day 22 of Advent of Elixir 2022. So in the original version, I showed you a new library that I had written called Spec, which is available on HexPM. I'll put the link down below. The basic idea was to implement the ets.fun2ms function, except in Elixir. I wound up adding even more to the library, and I'm really excited about it. It turned out to be a bit trickier than I expected, but I'm pretty happy with how it's turned out. Now that it's at version 0.3.0, I consider it to be feature complete. And all that's left to go to get to 1.0 is a series of property tests, performance testing and optimization based off of those performance tests, and any bug fixes that might show up, and I already have a few. Sponsorship on this library is open. I'll put the link below, and I'll be doing sponsorship on all of the libraries that I'm writing and also these videos via GitHub sponsors. Okay, so let's get started to demo the newest version of Spec. So the first thing we're going to do is we're going to create some data that we're just going to use in this demo. So I'm going to make a table. We're going to assign that to a new ets table. I'm just going to call it name, and we're not going to add any special parameters. So this is going to be a private ets table. That's fine. We're going to insert into the table 2 pieces of data. And I'm going to write this out explicitly because it's just going to make things easier to understand. Foo, which is going to have the value of 1, and bar, which is going to have the value of 4. So you can think of this as a key value store where we just have 2 key value datas, and they're going to be just 2 tuples. OK, great. So before we move on, the key thing to note is that in the Spec library, which I've imported into this project, most of the functionality lives in macros. And the reason why that's the case is because we're going to be using the Elixir fn Lambda specification as a way to define our match specs. So what we're treating our match specs as are functions, and we're pretending that we're writing a function. And if the function fails to match or throw an argument error, then it won't match in the match spec. But if it does, it will do what the function says to do. And I think this is kind of like a very good way of couching what an ets match spec is doing in a language that we're more familiar with and is easier to read. However, because we're not going to actually be making functions, and fn is kind of like a reserved syntax, we have to make it a macro. So in order to do that, the first thing we're going to do is we're going to require match spec. And what that'll do is that'll make sure that we have access to macros inside of the match spec. So the first thing we're going to do is we're going to look at fun2ms. So this is intended to be a rough equivalent of the ets fun2ms function. So we're going to do match spec.fun2ms. And let's look at a basic match spec here. And what we're going to do in this function is we're going to match on all values that look like a 2-tuple with foo as the first element. And then we're just going to grab the second element into a variable and then return it as as the result of the function. And so looking at the match spec, it's pretty straightforward. We have a match section here where it's looking for foo and binding the second part of the tuple to the variable 1. We have no filters, and it's going to return just the variable 1. So let's see what happens when we run this on the table. So ets.select table and the previous value, and then we're going to get 1. And that's exactly what we would expected, because if we passed this function along all of the members of this table, then we would get 1 back. And of course, it wouldn't match on the second one. OK, so let's now look at using a filter. So you specify filters in an Elixir function using the when syntax. And the great thing is that all we have to do is just write a function that takes a when value, a when guard here, and pass that to fun2ms. And what are we going to get? We're going to get a match spec that discards the first value here, or the first part of the tuple here, matches the second part to the variable 1. Then we're going to do a filter where we compare, using the greater than operator, the variable 1, the first variable, with the value 3, and then we're going to return the value. So if we were to run this function against the elements in this table, then we would expect it to return 4, because that's the one where the value is greater than 3. So let's go ahead and do that. And we indeed get 4. The other thing you can do in a match spec is you can modify your result. So let's do a match spec where we're doing that. And let me clear this. OK, so here we're going to just match against only the value part of this key value pair. And then we're just going to add 2 to the value. Now, let's look at the match spec for that. Here, again, we're dropping the first part of the tuple. We are matching against the second part. We are using no filters. And then we're going to apply this plus guard, where we're adding the value 2 to variable number 1. And so let's run ets.select on that again. And then here we see 6, 3, 6 being 4 plus 2, and 3 being 1 plus 2. So this match spec gives us exactly what we would expect if we ran it against this ets table. I do want to show you a few more of sort of the tricky things that can happen. So let's do match spec.fun2ms on this function. And so looking at this function, what we're going to do is we're going to match tuple. We're going to match a 2 tuple, and then pull out we're going to put the value part of this key value pair as value. We're going to drop the key. Then we're going to match we're going to assign the whole thing to the tuple variable. We're going to have a single filter. The single filter checks to see if the result of the guard lm with the full tuple and 0 as the arguments is equal to the atom foo. And then we're going to return the value. Now, this is not the most efficient way of writing it, but I just wanted to do it this way to show you a couple of the issues that are going to show up that happen when you try to convert functions into match specs. And here's kind of the key bit here. Let's take a look at the when part, which is going to be the filter. So that's the when part there. And so note that our comparison is not the atom triple equal, which is what you might expect. But in Erlang, the triple equal corresponds to this equal : equal operator. And so that's not the same as triple equals. Then let's look at this lm tuple 0. So tuple got assigned to the entire tuple here. And note that our match is going to just be $$1. Well, in order to retrieve the full tuple, what we have to do is we have to use this special special variable $_, which assigns to the entire match. And then we can't use lm because lm is not a guard in Erlang. It's only a guard in Elixir. And importantly, the corresponding guard is called element in Erlang. Note that 2 things about the element guard. The order of the arguments is different. So in Elixir, the tuple would be the first part of the argument because Elixir likes to put the subject matter of the function as the first variable, and then the index is 0. Is the second value. Here, the element, the tuple winds up as a second argument, and 0, which winds up getting turned into 1, is the first argument. And the reason for that is because element is 0 indexed, lm is 0 indexed, and element is 1 indexed. So it's key to remember that these sorts of transformations are apply when you try to write a match spec in Elixir. And the nice thing is that fun2ms will take care of all these things for you, and so you don't have to worry about it. Okay, so let's go ahead and select that again, and here we see the expected result of 1 because we've matched this tuple using the filter. So those are a few of the caveats. There are a few more. Map get is another one where you have to worry about the order. Erlang map get map get guard, and is map key has a reverse order in Elixir versus Erlang. Okay. So let's talk about a few of the safety systems in MS and fun2ms. And one of them, for example, is what happens if you try to give a function that has an arity of 2. There's no way to really turn that into a match spec. And because of that, we get a compilation error that says that function branches from match specs must have arity 1, and we got arity 2. So you simply won't be able to do this. If you were to do this at compile time, it would be a robust compile error with the correct, for example, if you were trying to assign an attribute to the result of a fun2ms, you would get this compile error that would tell you exactly where things went wrong in compilation. Let's look at the case where, say, maybe we want to have a usable 1 arity function, but we're going to do something weird. We're going to have more than one clause in the end. So let's say like some variable a equals 4, and then if true, do a. Okay, so this is perfectly valid Elixir syntax, but there's no way to turn anything like weird like this into a match spec. And so we're going to get this error saying that function bodies for match specs must be a single result expression, and we got a equals 4 if true do a, and that's not a single result expression. Again, if you tried to do something silly like this, it would trap you with a compile error. Okay, so the next thing that I want to show you is ms2fun, which is the reverse operation. What it will do is it will take a match spec and give you back the corresponding function that is associated with that match spec. So let's take a look. So we're going to use this match spec, which, I don't know if that's easy to read or not, but it's going to, and what we're going to do is we're going to output code. There are two modes for doing it. One which will output code, and one which will output AST. So if you wanted to go on and compile whatever that match spec was into an Elixir function, you could use the AST, emit AST, and then put that into some sort of a macro, or do a code.compile, and it would give you a usable function out of that without having to transition through textual code. But let's look at what happens when we do code, and we get this function out at the end, function v1, v2, when v2 not equal to nil, v1. So I think this is useful if you run into a match spec that you are having difficulty understanding. It'll translate it back into a function that you can read and think about using your Elixir code reading skills without having to basically learn how to read a match spec from scratch. We'll want to note that a few things are going to happen. The underscore, a $_ underscore, the $_ underscore thing, we don't know how to give that a name to the variable, so I wind up calling that tuple. And there's no way to backtrack and recover the names of variables, so we just wind up with these sort of generic v1, v2s as the names of the variables, and they've lost contextual information. And what you will have to do as somebody who uses this as a tool to help you read match specs is to kind of use your head and figure out what exactly we mean by v2 and what exactly their roles are in the match spec. Okay, so that's ms2fun. So since the previous release, I've also created a couple of extra really interesting macros. And the first one that I want to show you is def match spec. And what def match spec does is it basically creates a Elixir function that can take variables and then put those variables into the match spec using a function-like syntax. This syntax actually winds up looking quite a bit like the x2ms library, but I do think that this is a better use of it, because in this case we really are encapsulating something where we're creating a new function, and we want to have a somewhat of a DSL when doing that. And what these when statements will do, when arrow statements will do, will basically create a match of branches. Okay, so taking a look at this, let's take a look at this match spec. We're going to create a my_ms, and we're going to pass it some key. It can be whatever we want. We're going to match that key variable as a pin here in the function head match. And then we're going to actually use a guard here as a we can use a guard here as a match variable, or as a filter, and then we're going to output this result here. So let's take a look at what happens when we do my_ms, and then let's make the key be foo. Oops, advent.my_ms. And so here we can see that it has generated the corresponding match spec for this. We're going to match the variables 1 and 2 against the key and value. We are going to make sure that this one variable is equal to the foo atom. And then we're going to have a second filter where we want to make sure that the value is greater than 3, right? That's here. And then we're going to respond with the sum of the retrieved second variable with the value 1. Okay, and so of course if we ets.select the table with this, right, we should get 5. ets.select, and why didn't that work? Oh, that didn't work because nowhere does our foo value is less than 3. So so here we got foo 1, and bar is one that's greater than 3, so none of them matched, and we got no results. Okay, that's great. Cool. However, if we go ahead and do ets.match bar, which is the one that does have a value greater than 4, we get a slightly different match spec. And if we select this, then we're going to get 5, because here our bar value has 4. That matches with the second condition, and then we get a match, and then we return 4 plus 1, which is 5. And so I think that this is super useful because in many cases you are going to want to have a match spec that is variable, because say you're searching through a key value table and you've got some user input value, or maybe you're looking through a registry and you want to match against a PID that's transient and only exists at some point in time. and that needs to be a variable item, then you can use this you can use this def match spec to create a resolution for that. So the last thing that I want to show you is fun2ms. And so let's go ahead and spin that up. And fun2ms is for when you want to have something like def match spec, except you want it to be a lambda. So let's go ahead and use that. So match spec.fun2ms. And what we're going to do is we're going to write a function that's similar to this, although we can't use the isBig when we can't use isBig here because that's private. And as a second parameter, what we're going to pass is we're going to pass a list of variables that are going to exist on the outside of the match spec. So here in this case, we've pinned key, and we need to make sure that the lambda itself can take key. And so here we've gotten a lambda, right? And I'm going to actually assign that to the lambda variable. And so suppose we did lambda.foo. You can see it'll generate a similar match spec to what we had before. And if I do lambda.bar, it'll also give you the same match spec as we had before, except here it's going to have bar, and here it's going to have foo. Fun2ms also has variants where you can do def and defp if you prefer to use those. If you prefer to use that sort of a structure instead of having a def match spec. Sometimes people prefer not having a use statement and having an explicitly obvious macro to generate their own functions. So yeah, so that's a tour of the match spec function or match spec module that I built for the advent of Elixir and now has been basically finalized. So please use it. If you really like it, you can sponsor me. And I do want to say that in the short time between when I activated sponsors and have made this video, I already have one sponsor whose GitHub handle is @dvic, and I believe his name is Damir Vandic. Thank you very much. I very much appreciate you supporting me making these videos and writing awesome Elixir libraries. And I will, if you are watching this as part of the Advent of Elixir series, I will see you in video 23.